Imagine a civilization so advanced it could capture all the energy shining on its planet, or even the entire output of its sun. What about the combined power of every single star in its galaxy? This isn't just science fiction, it's the foundation of the Kardashev Scale, a way scientists classify cosmic progress based on energy usage. Even though it sounds like something out of a space opera, the Kardashev Scale is a serious scientific tool, used to frame our possible futures, evaluate alien worlds, and challenge us to imagine just how far humanity might go. Let's start with what the Kardashev Scale actually is. In 1964, Soviet astronomer Nikolai Kardashev proposed a simple, bold idea. Define a civilization's level of advancement by how much energy it can harvest and control. There are three main types. Type Y, known as a planetary civilization, can use all the available energy of its home planet. Type 2, stellar, can harness the total output of its star. And Type 3, galactic, can wield the energy produced by its entire galaxy. Each jump represents not just a change in technology, but a radical transformation of society, ethics, and even biology. So where does humanity stand today? Not even at Type 1. By best current estimates, using the mathematical expansion proposed by physicist Carl Sagan, humanity is about course 7 on the scale. We use lots of energy, but we still rely heavily on fossil fuels, extract only a sliver of the sun's power, and struggle to translate our growing needs into sustainable practices. To reach Type 1, we'd need to master every energy source on and above the planet: solar, wind, geothermal, tidal, nuclear, even tapping the sun's energy with massive arrays in space. Turning Earth into a Type 1 world is a centuries-long project. Optimistic projections put us there in about 100 to 300 years, somewhere between the years 2100 and 2400. That means rapid shifts toward global electrification, the rollout of safe and efficient fusion reactors, orbital solar farms storing sunlight for rainy days, and a seamless global energy grid. It also means solving massive social and environmental puzzles, eradicating poverty, stabilizing the climate, replacing fossil fuels, and stewarding the planet's resources for everyone's benefit. Achieving this raises big questions. Can nations cooperate so closely, or will we need a new kind of planetary government, transcending today's patchwork of borders and interests? Scholars suggest that such a civilization would likely require unified, or at least deeply federated, global stewardship, just to keep the vast machinery of a Type 1 energy system running. What comes after Type 1 is truly staggering. Type 2, the power of a star. Picture a network of satellites and habitats surrounding our sun, absorbing vast quantities of solar energy in a so-called Dyson sphere or Dyson swarm. This structure wouldn't be a solid shell, more like a cloud of millions or billions of collectors, converting sunlight into electricity for use throughout the solar system. Even a partial Dyson swarm might reveal itself to distant telescopes. Astronomers have looked for stars emitting a mysterious excess of infrared light, the telltale glow of waste heat from alien megastructures. Alongside this, future stellar civilizations might try starlifting, extracting stellar material for fuel, or building enormous computers, a matryoshka brain, to process information on an epic scale. The leap to Type 2 isn't just a matter of building bigger solar panels. It means gaining the ability to engineer on an interplanetary scale, mining asteroids, assembling self-replicating factories in space, and solving the challenge of moving people, materials, and information throughout the solar system. The timescale? It's far more daunting. Thousands, even millions of years, depending on how rapidly technology progresses and how much society is able to coordinate these Herculean efforts. Beyond that, the ultimate frontier is Type 3, civilizations that span and control resources across an entire galaxy. For this to happen, a species would need to colonize thousands or even millions of solar systems, constructing Dyson swarms around many stars. They might engineer black holes to extract colossal amounts of energy, or even manipulate space-time itself, building networks of wormholes to bridge the cosmic gulf. At this point, the dividing line between an individual and the collective could blur. Some futurists suggest that an advanced civilization might evolve into something like a galactic hive mind, sharing consciousness across vast distances. Physicists like Carl Sagan and Michio Kaku note that these societies would be as incomprehensible to us as we are to simple animals, though they'd still be bound by the universal laws of physics. On such grand scales, time also stretches, progressing from our current position to galaxy-spanning civilization could take millions to hundreds of millions of years. Even a fraction of this achievement would radically transform not just technology, but language, culture, philosophy, and even the definition of what it means to be human. But the Kardashev scale is about more than physics. Each step up brings profound social, political, and ethical challenges. For Type 1, managing Earth's resources will likely demand a level of global governance and mutual trust never seen before. National identities might fade as humanity unites under a single stewardship. Economic systems could shift from competition for scarce resources to collaboration for planetary well-being. Basic needs would be met for all, eliminating poverty, giving everyone access to material security, and freeing up energy for creativity, exploration, and meaning-making. As we venture toward Type 2, new forms of political organization might emerge. Imagine independent space nations, federations between Earth and Mars, or corporate colonies in the asteroid belt. Concepts of identity and citizenship could become more fluid, as people born on distant moons see themselves as members of entirely new cultures. The integration of artificially enhanced minds and digital entities into these societies could radically change decision-making, laws, and conceptions of rights. Does a sentient AI deserve the same rights as an organic person? Would synthetic life, designed from scratch, be considered human? The rise of transhumanist technologies, gene editing, neural implants, even the possibility of mind uploading, raises additional questions. Will inequalities grow if only some can access these enhancements? Could post-human elites wield power over ordinary individuals? At Type the Thread, these challenges become even more dramatic. A civilization spread over trillions of stars might experience consciousness not in individuals, but as a vast, interconnected entity. Philosophy, ethics, and culture will evolve in directions impossible to predict, but certain dilemmas will remain. What responsibilities do post-biological minds have to the physical universe? How do multiple conscious entities, perhaps distributed across light years, coordinate their decisions and well-being? Would notions of individuality and privacy even matter at such a scale? Fast-forwarding through these future milestones requires not only technological breakthroughs, but also biological and cultural evolution. Biomedical advances, gene therapies, bionic limbs, artificial organs will make us healthier and longer-lived. Neural interfaces may boost intelligence, allow mind-to-mind communication, or create blended realities that feel as real as our current world. Pushing this further, some envision a day when consciousness itself can be uploaded, existing as digital patterns in hypercomputers instead of brains. The identity puzzle this presents. Are you still you if your mind is copied into code? Will spur new schools of thought and legal rights. As abundance grows, so too will cultural shifts. Work may become optional, as most goods and services can be produced automatically by self-replicating machines or nanofactories. Money could lose meaning as food, shelter, healthcare, and information become free or almost free. People may choose to immerse themselves in virtual worlds, join communities spanning planets or servers, and devote their lives to science, art, or exploration. Diasporas in space might develop new languages, religions, and customs, reshaping what it means to be part of a unified human species. Of course, this journey isn't guaranteed. Our path is fraught with existential risks, steep bottlenecks that could stall progress or extinguish civilization. Environmental collapse, whether by runaway climate change or depleted ecosystems, might destroy our planet's habitability before we reach Type 1. Technological disasters, nuclear war, engineered pandemics, out-of-control artificial intelligences could likewise undo centuries of progress. On a cosmic scale, supernovae, gamma-ray bursts, or asteroid impacts remind us we're always at the universe's mercy. Some philosophers call this the Great Filter, a barrier that most civilizations may never cross, explaining why we've yet to see evidence of aliens despite the scale of the cosmos. But what about those hypothetical alien civilizations? The Kardashev Scale isn't just for humans. Astronomers use it to guide the search for extraterrestrial intelligence. SETI, a Type I alien society, might be detected by the glow of their cities seen on the night side of their world or planet-wide radio broadcasts. Type II aliens could reveal themselves by building Dyson swarms. Telescopes already look for stars emitting excess infrared, known as waste heat, the theoretical byproduct of these megastructures. Several candidate stars with unexplained infrared signatures have been found, though most turn out to have natural explanations. A true Type III civilization might manipulate not just stars, but the architecture of entire galaxies, transforming the shape and light profile on an intergalactic scale. So far, no confirmed signals of advanced civilizations have been found. But the search continues, not only in radio frequencies, but also in laser pulses, heat signatures, and unexplained anomalies in the light of distant objects. As we continue to refine our methods and share knowledge globally, we increase the chances of spotting something as monumental as cosmic engineering in another corner of the universe. In the end, the Kardashev Scale challenges us to think big about the tools we build, the societies we shape, the values and identities we'll have to rebuild again and again as we climb higher. It's about more than power plants, solar arrays, or megastructures. It's a question of human destiny. Can we survive our adolescence, cross the thresholds of energy and wisdom, and join the ranks of cosmic civilizations, if any are out there at all? By studying the Kardashev Scale, we aren't just speculating about the far future. We're preparing for it, one step and one breakthrough at a time.